Hello YouTube, welcome back to the Vacuum Breather channel and my devlog on the Montreal project. This time I'm going to focus on some Hex-Grid algorithms that I implemented. And I want to give a little shout out here to this website, Red Blob Games. He has a blog entry here that is a little older but has been updated recently, that has a ton of resources on Hex-Grids, layouts, algorithms, and a ton of actually very fun interactive things here to play out with, very well written. So it's definitely worth checking out. It's just redblobgames.com, so check that out. But let's jump right back into the editor and actually figure out how this works. I have a testing layer here in my testing scene where I can set a couple of algorithms that I want to check. So let's start with simple selection, which is of course very easy and very trivial once the editor fires up. It's just selecting the current hex that my mouse pointer is over. Very trivial, but also very useful for obvious reasons. The neighbors algorithm that you also need for pretty much anything in terms of pathfinding, but you can also use it for all kinds of other stuff. Then diagonals, which gives me these hexes. And then I have a distance function where I can click on anything and then I get a distance up here to whatever hex I'm on, how many steps it is from that hex to whatever other hex I go to. Then I can draw lines, which is actually a little bit tricky to do. The line algorithm itself is not that hard, but sometimes you can get a line that is outside the actual field with some algorithms. So I had something added where I give it the bounds of the map and it shifts the line that is drawn from the center of the hex slightly towards the center of the map. And that basically makes sure that not only if you have a line, let's say, that goes like this. Obviously, if you go from center to center, you end up at this point right exactly between two hexes. And then if you tell the grid in Unity, okay, which hex is this actually a part of, which cell is this coordinate in, depending on rounding errors, it might end up either to the left or to the right. And in order to have that a little bit consistent and make the lines look nicer, you shift the point slightly into one position. I think I go 1% of the cell size in one direction from the center, and that makes sure it shifts it always in the same direction and keeps the lines nicer looking. And since I'm shifting it to the center of the map, I'm also making sure the lines are also always within the bounds. So this is obviously useful for certain paths. In my case, it will be the check for airplane paths. Since they don't use pathfinding, they use direct lines, but I still need to know which hexes they go through to do stuff like, checking zone of control if they collide with any other unit or whatever. Then we have breadth first search, which in this case is not really all that interesting. I can, however, block some hexes, and then you can see what this is actually doing. If I load a preset here, then you can see it even better. If I block some stuff off here, it only fills this. And if I do it asynchronously, which means I have an asynchronous method where I can give it some stuff to do whenever it visits a hex, then you can see what is actually happening here. Let me make this a little bit slower maybe, so you can see how it slowly searches every cell. Obviously, I can use that later with the painting of the map to fill certain regions with certain tiles, but I can also use it for all kinds of stuff. Breadth first search is basically a fill algorithm that visits every cell that it can reach, and that is useful for all kinds of things. Then I have breadth pathfinding. As you can see here, it uses that same algorithm to find a certain path to a certain position. Obviously, in this case, not yet using the terrain points. That's where Dijkstra comes in. That actually uses the cost of the algorithm. And here you can see the cost of the terrain, the cost of the hex, or rather the cost of moving from one hex to the other. As you can see here, it is already avoiding the forest, So that's already working nicely, but it is still using a lot of hexes to look that up, and that's of course where shortest path, or in this case a star, comes in. And you can see it uses up a lot less tries to figure out which path is actually the closest. I actually figured out that in this implementation they don't necessarily come up with the same solution, but they come up of course with the same length of the solution, not necessarily the hex length, but of course the same shortest cost of the path, and that's of course what we want. And then we have ground range, where I can also use the breadth first search, limiting it to the cost of movement points that I can enter here. In this case, how far can I get with 3 movement points? That helps me with that. And the air range, of course, is pretty simple. That limits just in the air and potentially blocked hexes, of course, if I need to fly around those. And finally, we have a field of view, which might not be obvious what this is doing. It might be more obvious if I go to a different map. Let me quickly switch out to this map here. I think it will be a little bit more obvious what is happening here, especially if I increase the view range a little bit. Here I basically let it calculate what I can see from a certain position in case forest tiles were blocking. I implemented it so that the first forest tile I match is still visible, so I can actually see that forest tile, but I can see nothing behind it. So as you can see, if I move around here, I get certain visibilities. Now this might not be optimal yet. This is of course something that needs to be tested later on, whether this is actually something that is intuitive for the player or whatever. Also this might have some issues where there's some disconnected hexes that don't really make all that much sense that they would be visible and others not. But for now, and with the low visibility ranges that the units will have in the game that I'm implementing here, I think this is actually an interesting concept. It's just a game mechanic that I play around with. I'm not even sure that I'm going to use it, but I thought, why not have that algorithm in here as well? So that's something that's interesting. Let's jump right into the code to see a little bit on how I did this. Everything is, of course, in this nice static helper class, where I also have the different direction vectors in cubic format to go from one hex in a certain direction, including the diagonals. This will actually change, since I might decide for a flat top to point top switch, or rather from point top to flat top after all. But it's actually pretty easy, since if you switch from Unity in the tile map from one orientation to the other, it's basically just switching out the x and y coordinates. So everything basically stays the same. You just switch 2 coordinates around, and then it switches to flat top. Obviously, you can see here the flats are pointing in the left-right direction, and the points point in the y direction. So if you just switch that around, the points will be to the left and right, and the flats will be at the top and the bottom, and that's exactly what's happening. So all these algorithms say exactly the same. I just need to switch x and y. The only thing that I need to change then is rename these vectors, and I'm probably going to do that with some compiler flags, where you can just set a define whether you're using point top or flat top, just to get these names wrong, or I'm going to prefix them with point top, flat top, whatever, because obviously then east is no longer east, but it's probably going to be north or south or whatever, either one of those. But aside from those names, everything will be exactly the same. The cube directions will be the same. The diagonals will be the same. They will just have to have different names to make sense visually. Everything else will just work fine. I don't even need to switch x and y in these algorithms. I just need to switch it wherever I display it to the user. Like up here, I'm obviously displaying the coordinates of the hex, so I would need to switch that around, so it makes sense that x actually still goes from left to right and not from top to bottom. So that's a nice thing about these algorithms with the way Unity does the switch. They basically work no matter which you use. You just need to remember if you display to the user switch X and Y around. So we still have offset to cube and cube to offsets. I previously had that at extension methods on a vector extension class. But I have them now here on the actual vector extension class. I can switch vector 3s to vector 2s by just removing or adding a z component. But here, the switch from 2 to 3-dimensional is actually one that switches from offset to cube coordinates. And this is not overflow safe, so if I go towards int max or anything, weird things happen, but most of the rules about these conversions actually still hold. For example, the cube coordinates in this case have the rule that x plus y plus z is always 0, which you can see if you look at one of these coordinates. This is -3, -5, +8, which obviously is 0, and that's the case pretty much anywhere. And that's still the case if you have an overflow, so for some reason that seems to work. But I'm not really bothered by that, since I will just never get there. You will never have a map where I get even close to an integer maximum, so I'm not really bothered by that. Nor where I know an easy way to prevent this. But it seems to be numerically stable, so even if you go beyond integer maximums, I actually have tests about that. If you convert it back and forth, you always end up with whatever you converted back. So if I convert from offset to cube and then back to offset, you end up with the same offset even if you're at the maximum limits. So that is numerically stable. That's all I care about. You can get the neighbors, including neighbors with a predicate. Obviously, we need that since we need to limit it to any neighbors that are actually on the map. Same with the diagonals, the distance function, and the getLine function, which in this case takes a grid and the bounds of the map. The grid, I want to pretty much detect which cell a point is located on. You can do an algorithm or a function to do that mathematically yourself. But since we have the grid, and that is the more consistent one, since I want the same logic involved with where a real-life point or real-world point is on the grid in terms of cell to local coordinates and back again, since the grid is already implementing that, why not use it for consistency? The local bounds are optional. That's the shifting towards the map center to make it a little bit more stable. You don't always need that, obviously, but if you care about having a line always be within the bounds of the map, then you can provide that. Then I have my breadth first search. This is basically all mapping towards a single method that is basically used for almost anything. That is, actually, it's this one, perform search async. And here I can give it a bunch of parameters, and basically everything Dijkstra and the first, the shortest path are all matching towards that. If I go into that, you can see there's a whole bunch of parameters, and it's actually an async method. This is actually not right, by the way. This needs to be a UniTask. I need to switch that around. But I'm actually using this from a library that implements a lightweight task that is also limited in scope to the actual game object it is running on. So that is something that I want to use that is very allocation free. It basically is based on value task. So unlike normal task, it is not allocating all over the place. And if this finishes synchronously, it doesn't cause any overhead. That's why I make it async by default. And basically we have a frontier and a come from and a cost so far, which is what you expect from a normal A star. But the thing is, the get heuristic and the cost function are something that I can give in from the outside. So if I set the cost to basically be constant, I go back to from Dijkstra to breadth first search. And if I don't provide a heuristic, we're obviously not an A star, because that's what makes A star A star. So this is basically just a fancy way of unifying all these into one thing, because they actually do all the same thing. The priority calculation for the priority queue is also developed by the cost and the heuristic. So if those are both constant, then obviously the priority queue turns into a normal queue that turns you again down to Dijkstra or breadth first search. So that makes it easy for testing. If this works, all the algorithms will work. And then, of course, I have field of view, which is not the most performant algorithm probably, since we basically go to all the cells in range and we draw a line to them and check whether any cell along that line is blocking. Obviously, that's checking a lot of stuff. But since my field of view will be pretty limited, basically just 3 fields in distance or maybe 4 or 5 at a maximum, that shouldn't actually go into those many cells, so this might actually be fine. It's more the algorithm itself, whether that actually returns the field of view that I expect and is the most intuitive. The other thing that I wanted to mention, obviously, is that I'm using UniTasks now, which is a very useful feature. It's, I think, written by the same guy that wrote UniRx, which I'm also using heavily now. And that is a very nice way of using asynchronous stuff without having a lot of overhead. And these tasks are auto-canceling if the game object that I started them on is no longer valid. So unlike the normal tasks that just keep going and might then run into problems that whatever game object that launched them is no longer present, it has been destroyed or whatever, then update functions or return stuff is causing all kinds of headaches. This just auto-cancels whenever my current context is no longer valid. So that is very helpful. And I need to remember changing this because that was not supposed to be a normal task. Should check my code base whether I'm still missing some task somewhere, because that's how I initially implemented it. And another thing is, of course, Rx in general, which I'm using heavily now. Among other things, in my component base, I switched around how I deal with messages now. Now, instead of having an event aggregator somewhere, I'm basically just using the Rx message broker now, which comes with UniRx. And I can publish an event now, and I can receive one. And as you see, I'm also checking for prefab mode, because for whatever reason, when I'm in prefab mode, these events still get called. And I end up with all kinds of strange stuff happening. So, by the way, if anybody knows any better way to check whether they're in prefab mode than this, that's the only way I could find it online. I'm guessing if the scene path is null, but the scene still has a name, that is the prefab scene. So I'm hoping that this will still work once later we do prefab editing in context, which is coming up. So anybody that has a good idea on whether to figure this out in a better way, also at the Unity team, it would be cool if we had an API for this. If there is one, I couldn't find it. So that is a question for the community out there. But aside from that, I can now just do this, and if I go at an example, for example, the input system, for example, that checking the mouse buttons, here I do basically on every update, I check certain stuff, and then I just publish a new mouse button down event, giving it the mouse button and the mouse position, and all these events are just normal structs now that give access to this stuff nicely, and hopefully also do a toString so I can easily see and debug what is actually happening in the log. And here you can see I can receive a mouse button down event, check a whole bunch of stuff, and then publish a cell clicked event in case we're on the map, and all that other stuff that we need to do here. The mouse button pressed was actually the left one, and all that kind of stuff. So then I also, after every receive subscription, I do this, add to subscriptions. That is also something that was recommended by UniRx, which is very easy. Subscriptions is just a composite disposable, which is in general just a disposable where you can stuff other disposables into. And then whenever you do that, you can throw that away and clear it. I think I told that already in the last one, because I think that is unchanged. I just shortened the name to subscriptions instead of event subscriptions, because that is a little long having that in the call. And that is basically it for the changes that we had in the recent versions. The next stuff is just adding some UI and actually be able to switch the turnaround, which obviously in a turn-based game is pretty important. So that's where we're at. I think in terms of Hex-Grid algorithms, I have everything I need so far. So now it's going into the actual gameplay a little bit more. I'm actually also using the .tweens thing, .tweens library. Let me go back. Where are my scenes? Sandbox. There we go. I also might need to reorganize my folders here a little bit more, but that is a work in progress. As you can see, I already have some stuff in play here, but I'm going to talk about that later in a later episode. But as you can see, the moving part is still working fine, and they're actually moving along the path that they're supposed to now. And I've implemented that. If I look into the unit real quick, here we are actually in this moving function. This is what I was talking about. I'm using .tween sequence, and I'm for eaching over it, adding a callback for the facing direction before each step, then doing a linear interpolation here and a sign in out for the entire thing. And then I'm awaiting the yield instruction, and that's basically what I'm doing. This is not much different than what was here before, just I now do an animation from every cell to the other, so I don't do it in a straight line, but actually following the path. And that's it for today. Next time I will go a little bit more into the turn switching once I implemented that all around. And I may also go into a couple of other things that I needed to research, like how to set up the UI. And soon we might go into combat and AI, and then it will get really interesting. So until then, keep heads up, folks. Hopefully you're surviving quarantine fine, and I'll see you on the next one.